So my name is Robin, and today I'm going to be talking to you about Befunge, this fun little language, and hopefully making what I think is beautiful about it like accessible to you, and showing off tools that I've made that other people can use to like understand and appreciate how Befunge works and what it is. So the general structure of the talk, we're going to talk about just address why are we talking about Befunge very briefly, then just describe what it is and its key concepts, and go through a brief whirlwind tour of its instruction set, and then do some more demos and wrap out about sort of like a forward-looking thing about kind of extending Befunge in the future and what I think there's the room for that and that exists. So first of all, why Befunge? Why are we talking about Befunge? None of you are going to leave here today with really Befunge skills that you'll be able to use to get Befunge jobs. You know, it's not that kind of talk. We're not going to save free software with Befunge. Unfortunately, that would be fun. There are a few different reasons, really. I think it's beautiful. I think people might enjoy that aha moment when they get Befunge. I think there's a chance that some of its concepts translate to other things, and so maybe you'll understand those things better. But ultimately, it's fun to put effort into things that you can't always justify. And so in short, I just think it's neat. But what is Befunge, right? I've said Befunge maybe 30 times. What is it? Fundamentally, it's an esoteric programming language. It's a very small one. Like the amount of text that you need to describe what all of the behavior of Befunge is quite small. It's not expansive, thousands of instructions and complexity there. But it is, the little bit that there is really weird in a way that makes it hard to compile and often hard to write, because it's sort of a confusing structure. And we'll dissect that structure in a little bit. Now, in terms of the history of Befunge, the original version of Befunge was made in 1993, and its name is Befunge 93. It's a fairly simple structure. And in 96, there was a successor that was made by the original creator that added some weird things to it that people ended up not seeming to like that much. It's not a very popular version of Befunge, but it does exist. And then people came together and made Funge 98, where they went and said, let's extend Befunge. And it's this two-dimensional thing into one-dimensional and three-dimensional versions and add a stack of stacks. And they really blew out the complexity to make this really massive thing. And I thought that kind of missed out on part of the point of Befunge. And unfortunately, I wasn't able to provide input to the design of Befunge 98 because I was busy being born that year. And so the name Befunge comes from actually just a misspelling of the word before. The creator saw somebody typo that and thought, Befunge, that's a weird word. That's fun. I want to put that as the name of something. But retroactively, the name kind of has been assigned this new meaning where we break into this prefix and suffix ba and funge. Ba meaning by, meaning two, because it's two-dimensional, and funge meaning fungible, because as you'll see, we're able to move things between this grid and this stack in a way that fungibility is this concept that seems applicable. So in terms of key concepts of Befunge, first of all, most programming languages that you've ever used, conventional programming languages, are line-oriented. Your program is made up of a sequence of lines, maybe statements and expressions, what have you. In Befunge, however, you have a grid. And every character in your Befunge program is in its own cell and is its own instruction or can act like data. And so you don't have lines of tokens, you have grids of cells, right? That's kind of the structure we have. And we're in a line-oriented program, everything is sequential, right? Lines come after each other. Every token and line has a before-after relationship. In our grid-based paradigm, every cell is above or below, left or right of other cells. It's directional in two dimensions. And so, for example, program execution always starts in the top left, going to the right. And you continue to go in the same direction you're going in until you encounter certain instructions that change the direction of flow. So the ones highlighted green right here are all instructions that change the direction that we're going. And so the implied arrows between them is the actual flow, whereas here we're just looking at the grid itself. This is the actual flow analysis of how that program will proceed. And then in terms of data, we've just done kind of the program flow and what a grid is here. The data flow is based on a stack. So every one of these gray cells at the bottom is the instruction that we're executing, and the things above it represent the stack at that point in time. So if you execute a 3 instruction, you get a 3 on the stack. That one's nice and simple. And you do an 8, we get an 8 on the stack, and so on and so forth. We can see that executing each of these instructions often takes operands off of and pushes results onto a stack. That is like the primary mechanism of data flow. And it turns out that you can compute the same thing multiple different ways. Here we've like moved the 7 further back up the ordering. You may notice that this is equivalent to like a postfix notation, or if you've heard of the term like reverse Polish notation, like that is kind of how you're gonna have to write things. So you would say if you want to like add 2 numbers and then multiply another number, it's, you know, AB plus C times, right? Not like A plus B. It's postfix in that way. Yes, those are 2 different things that both compute 75. So now we're gonna get to the first part of the demo. Actually, we're gonna exit this and go and run stacker, which is just a little example program. And hopefully you all can see this. I know this is kind of small, is hard to resize things, so it'll be big enough for both of the demos that we'll have later. But the basic gist here is that this is just a loop. This is, you know, program flow executes to the right, then down, then left, then up and right and down. And what this program does very simply is push data onto the stack forever. So like, well, it's 1, 2, 3, 4, 5, 6 on the stack, and you can see on the right side the TUI, this terminal user interface for the Befunge debugger, will show you the contents of the stack over time. And so on the left we see the grid, on the right we see the stack, and this is just sort of visualizing those 2 concepts that I was just explaining a second ago. Now we're going to do that whirlwind tour of the instruction set that I promised. So first, our kind of first 4 most important instructions are our directional arrows. And these aren't actually like Unicode arrows. It's all ASCII, so it's using the letters that we have. So we have caret and V as our up and down, and left and greater than as our left and right. We also have 10 instructions that are the decimal literals. They push what they say they are. This does mean that you can't push 70. You would have to push like 2, 5 times, you know, et cetera. Like you'd have to build up to those numbers, which does make it weird to write literals of any like numbers bigger than 9. We have a few conditional flow instructions. So like if you execute an underscore, it'll pop the top value of the stack. And if it's 0, you'll go right. If it's not 0, you'll go left. And we have equivalently the pipe instruction, which does the same vertically up and down. And so the lines sort of represent the direction of travel that you might go. Finally, in terms of our like main control flow direction instructions, the question mark just sends you somewhere. This combined with the decimal literals is how you make random numbers. You make question marks that send you in random directions, and you encounter an instruction that pushes a random number, and you do that some amount of times, and you get numbers of the variety that you want. That's how you make random numbers. We'll see that in the less more example here in a second. So let's do that. Let's do less more, which is so this is a guessing game program. There are 2 major structures going on here. There's like a few structures, but on the top left we see these 2 spiral shapes that you might notice. And if you can see, I don't know if you can, but like there's a question mark in the middle and like 3 question marks around them. And so what's happening is we're going to branch in one of 3 random directions, and then we're going to branch in one of 3 random directions, and we'll pick up a 1 through 9. So if we just step some number of times, like here we've made the first decision, we've decided to go right, and then we've also decided to go right again, just by coincidence, and we've picked up a 5. And on the right side of the stack view, we can see that there is a 5. And if we go around again, we go through the second spiral. And if you saw that it actually went backwards that time, it had to like re-enter the randomness. That's how we keep ourselves from backtracking, because there's just another right arrow in front of it. So if you go left, it'll send you back in. Whoops. And then we picked up a 9 this time. Yeah, and I think then we go back. Anyway, so let's talk a little bit about arithmetic instructions. We have all the basic ones that you might expect for integers. They all pop 2 values and push 1 value, fairly straightforward. The only ones that are finicky is divide and subtract. Bit of trivia, like one of the original specifications of Befunge said that if you divide by 0, you should prompt the user for what they want the answer to be, because it could be anything. I don't implement that, but that is the joke answer of the spec. We also have this thing called quote mode, so if we encounter a quote, we enter quote mode, and instead of executing instructions while we're in quote mode, we just push their values. So instead of like trying to execute an A, which isn't an instruction at all, we just push the value 97 and then 98 and 99, and we enter the other quote, and we leave quote mode, and we would continue to execute instructions normally at that point. Last, in this, or we've got 2 more slides before then we go back to the demo. This one's logical comparison. We have a greater than. We obviously can't use the greater than symbol because that means go right. So instead it has backtick. That's just what we've got to work with. And then the logical not, it just says, you know, if we have a non-zero value, make 0 be what we put on the stack. If we have a 0 value, make 1. And so it just lets you invert logical things. Lastly, for this section, we have 4 instructions for reading and writing letters or numbers. And so if you execute the ampersand, then it'll actually prompt the user to type a number. It can actually be multiple digits. It's actually not just like prompt for digit, it's prompt for number, which is interesting. And period prints a number. you can also take in just a character. You can also just write a character. And so these are kind of our 4 I/O instructions for interacting with standard input and standard output. So the next thing that we'll do, we have 9 and 5 on the stack. So after we execute this asterisk right there, we'll have 45. And this is the random number that the less more game has chosen. This is what we'll be needing to guess. And then it's pushing this string onto the stack in quote mode. And then there is a little loop here that's, oops. And we'll just run this for a bit. And this loop is going through, let's go to the other tab, and is printing out input number. And now we've just encountered our ampersand. It's going to prompt us for a number. Would anybody like to guess a number that's not going to be the answer? 4. Or 15, was it somewhere? Or yeah, let's do that. So we guessed that number, and it said the number that we want is greater than that. Would anybody like to guess the actual answer? So on our stack view, we see that the answer is 45, of course. So we can go here, and if we do that, we'll see that we win. Huh? Oh, no. It takes a little time. Yeah, it's a little shaker. So that right there that we're seeing. Oh, I'm realizing there's actually an instruction that we won't get to, but anyway, we'll finish the ones that we do have. So there's the stack manipulation ones, in order to just help you do some operations, like for example, because direction changing, the underscore and the pipe take a value off the stack. If you need to use that value again later, you might duplicate it first. You might swap values if you want to access 2 values on top of the stack at this kind of alternatingly. And you might delete a value if you've duplicated something and then in one branch you don't need it. So we have those. And finally, the thing that gets us to kind of the full concept of Befunge is that we have the ability actually to modify the program grid itself. And that is what the P command does. And this is actually why Befunge is so difficult to compile, because during the execution of the program, it can change itself in ways that change the entire flow of the program. You can put a direction changing character in the middle of a line of a path of execution, and now the entire analysis of the program has changed. And this is what makes it so resistant to compilation. Yeah. And at this point, I was going to go back and finish the demo, but we kind of got ahead of ourselves a little bit, or rather I did. We'll continue on. I've also made another little toy. So the first thing, right, is this debugger. It has some features that I'd still like to get to at some point, including I've laid the groundwork for a time travel debugger. We have essentially a code that logs all of the events that happen while executing with enough information in order to invert them. And so it should be possible to set a breakpoint somewhere, run to it, and then back off of it and figure out how you got there, which is quite fun and not a thing you can do in most debuggers. Yeah, but let's start with the web demo. So, the web the TUI is great for a lot of people here. I'm going to make it installable on all the normal package managers. You want to play with Befunge, you'll open it in your terminal. That'll be great. But for a lot of just random people, if we want to just share Befunge as this weird, cool thing that exists, that's not actually the most accessible for a random person, especially if we're doing this, offering this to people who are early in their computer science journey or programming journey. And so the thought was what if, this grid, it sort of resembles tiles. Oh no, everything is so big. Yeah, let's try that. Okay. Oh yeah, that works well enough. So I made this just in bare JavaScript and CSS and HTML. We have this drag and drop environment that is not yet complete, but where people will be able to you'll be able to embed this potentially in your site, or alternatively, I'm going to zoom out again. You could make your own sort of puzzle game using the same library and code. And so I think there's an opportunity there to write blog posts explaining Befunge that include and to show that as you're exploring it, go plug in some pieces. So, the goal here is to compute the number 77. Do you think we've got this as a group? We want 3 first? What next? Right. Yep. Ta-da. Not exactly the hardest one, but just a little example of what it is that can do. How am I on time? Wonderful. Yeah, so there's this interactive environment. There's a TUI. There is this sort of browser-based environment. We'll go back and play with a little bit of those. I'm going to have, I think, some extra time at the end for Q&A and if people want me to try things in the UI to see them. But first, let's wrap up sort of the main points. So Befunge, we have a version of Befunge right now. There have been various variants of Befunge. There are Befunge 98 and things. I think there's room. when you're making variations of Befunge, I think there are like 5 core things that make up the identity of Befunge, like the like what is fungy about it, like what makes it what it is. And I think these are useful when thinking about like adding new things to the language. Like, do they fit in this framework? And so the kind of 5 themes that I've identified, at least, are that like the program is this 2D toroidal space where I didn't really get to that earlier, but if you fall off the edge on one side, you'll come back around the left side. It doesn't go off into the void in that direction. The program counter is 2D, and we're only moving relatively. You saw the cursor moves linearly. We don't jump to random points. That's kind of the way of Befunge. And every cell in the grid is an instruction, and instructions take operands off of the stack and also put their results on the stack, and programs can modify themselves as a grid. So these are like kind of the 5 major themes of Befunge, as I sort of like to think of it. And when you're like thinking about what you want to add to Befunge, like, and I encourage everybody actually to go extend Befunge. So like, and if I were doing that, where I would go and where I think I'd like to experiment is to start with Befunge 93. Like Befunge 98 is massively complex. It's like a really involved starting point, I think, and there's rooms to like make other design decisions that I would encourage people to explore. Befunge 93 does have the downside that it is ASCII oriented and that it has this inconsistency where its stack is 32 bits, but the program cell space is only 8-bit. So just make it 32 bits everywhere and do Unicode, in my opinion. I think that's just a better way to go. And then like with those themes that I was talking about earlier, like there's no reason that you have to stick to them, but that's sort of a guide for whether or not you're making something that is like another Befunge, like a Befunge dialect, or you're making something that is just derivative of Befunge, a Befunge inspired thing. And like, I think we have the freedom to do both, and like I think there's an argument for like maybe we should have a Befunge 25. Like, but let's imagine more things. It's been 30 years since there's really been much Befunge going on, but you know, Befunge revival in 2025. Why not? Yeah. Oh yeah. And whatever you do, please write a spec. The sort of the inherited legacy of Befunge is often like little silly things that didn't document themselves very well. And I think if we're gonna revive Befunge, we should try to aim to do better, just on the same front of accessibility that we've been talking about this whole time, of saying like, let's make it easy to write consistent implementations and to make toys and tools with it. Like, let's document what we do. Yeah, and so that's the main thrust of the talk. Thanks everybody. Here's like where you can find me, and also all of my talk info is available on my website, esoterra.dev. And there is a specific page for this talk that also has a link to its PDF and everything. Yeah. So does anybody have any questions? Yeah, shoot, go for it.
I've been pretty inspired by the Ken Iverson famous talk, notation level of thought, how APL has explored with
Right.
many things. And some of these things are in other languages, like self-modifying code and similar. And I'm just thinking about this because this makes certain things possible through its like kind of interesting 2-dimensional notation system. I'm just thinking, are there any parts of Befunge that you wish for maybe experiments with or tried out in not necessarily mainstream but non-ESOA languages?
Oh, like yeah. And to summarize the question a little bit, there's a comment on how like APL has some features that maybe feel similar, and that there are ideas explored in Befunge that may be interesting. And the question at the end of that was asking whether or not I think there are things that languages should take from Befunge, I believe. And like, is that so? Not really. If we're going to be entirely honest, Befunge is a fun experiment. Befunge is a conceptual way to approach like 2-dimensional languages. There are some parts of it that I think are interesting. So if you're going to pick something to use, then like a thing that is in use but in other places, and I kind of referenced this briefly in the beginning, like stack orientation as a way to make an instruction set is a thing that's been explored a lot. It's a thing that exists in WebAssembly. It's a thing that exists in Java bytecode. That's like a conceptually fairly interesting pattern. I think it's not something that developers really want to think about in terms of like the way that they write their code. Like writing in reverse Polish notation isn't particularly like pleasant. I mean, like we do the reverse like prefix with like Lisps and things, do like a prefix notation. But yeah, I mean, like the concept of moving operands off of and onto a stack, I think, is a fun concept for certain languages and like internal representations of a code, or intermediate representations, but probably not something that like end users really want to think about for the most part. I don't know. If we're gonna be abstract, maybe just more whimsy. You know, we could maybe do. There are some fun aspects of this that I don't know that you can translate them directly, but maybe people. I don't know, I guess there's a broader point here that I think it's it can be fun to pay attention to things that aren't really worth it. Like I said earlier in the talk, there's really no financial justification, no like direct way that any of us are going to be able to operationalize this. And that I sort of acknowledging that there's not really a thing that you're going to be able to take this into your, like the libraries you write and the code that you're doing for work or for fun or maybe for fun, but not for like good or work. But like not everything has to be, right? So like this idea that we can choose to zoom in on and care about things that don't matter anyway, and make weird little projects. Like, just want to encourage people to explore that. Yes.
I have one plug and one question. One is there's a really cool video game based off of Befunge called Space Chem. If you've ever played it, it's like space chemistry. It's very cool. You pick up atoms and you make molecules. They're also on the grid. It's very cool.
Yeah.
Question I had.
Okay.
Oh, good.
Well, I'll re-say the shout out. So the shout out was for a game called Space Chem. Chem as in chemistry, where you like combine chemicals together in some way, like using a grid, and where the chemicals are placed on a grid. And so it is Befunge-like and presumably Befunge inspired. And then the question.
And then the question was, I see you have the random number generator generates 1 through 9. That looks fairly straightforward because it's just 3 branches and then branch 3 more times. How do you get 0 into that mix?
There are a lot of things in Befunge that aren't convenient, and if you wanted to do that, like actually writing a good uniform sampling random number generator, I think you'd probably end up just sampling like 0 and 1 and shifting it a bunch of times. I don't think you would go with this like 3 branch factor squared thing. Like I would probably just have 2 options and redirect back towards the middle and do that enough times that I can make arbitrary binary numbers.
So you generate them at a different pace number system and then convert them.
Yeah, because ultimately, like at each stage when we're selecting a random path, we are selecting a single value. And so the number of select, like, is the ternary option that we have now better than, like, I would probably be easier to think about in binary, I think. Yes.
Thinking about like modifications or extensions to the function, the first thing that came to mind for me is parallelism or concurrency. Do you know of anyone who's exploring that already?
So there is a variant of Befunge, I forget what it's called, where they add a fork instruction where execution splits into 2 and the question was, like, are there explorations of like parallel programming or maybe like threading or forking in Befunge, and there is one. I don't remember what it's called, but it is out there, and there are lots of opportunities to do things like that, like to fork or to do non-determinism. There's a thing that was being discussed some at this conference. I think my favorite Befunge extension, if I was going to like pick one, is the idea of combining the hash command, which we didn't actually go over, I realized, which actually jumps over the next instruction. So you kind of hop over it like a trampoline, with the idea of the P and G commands, so that like you hop over, you make a command F for funge, we liked, where you hop over the next cell that you were going to visit if it didn't do this, and you drop the top value of your stack there and write it to that cell, and whatever was there you put on your stack. And so funge in the sense of like fungibility, in the sense of exchanging between stack and grid, but in a very local way. So instead of needing to, like, I don't know if people noticed this in the code here, but the way that it actually is able to do the like less than and then the less than equal is that it actually stores the value that you guessed in a place in the grid in a way that we don't visualize. And then it gets it again. But it just chooses arbitrarily the location 99 because that's the easiest thing to write in Befunge. You just do 99p, you know. But I think it'd be fun if you could use F and just drop it on the ground in front of you. And I think there's something cute about that, the intuition of being like dropping something down and hopping over it. It's like as a spatial metaphor. And so I think out of Befunge extensions, this is currently my favorite instruction choices is the funge instruction. Yes.
One idea that might be crazy to do is add an instruction to change the topology of the space.
Yeah, so somebody commented that one thing you could do is add an instruction that changes the topology. I would say that you definitely could do that, and that would be crazy. Do you have topologies in mind that you think it would change between?
Well, so you have like the 2D shape curve. You could do like I 0, 1 squared topology, where basically it's like a bunch of unit intervals stacked like this. So basically we start going down and then wrapping back up like vertically.
Oh, where like it shifts over as it goes down, like when it loops over. Yeah, you could do things like that. You could also make it so it's like a Mobius strip. So if you'll arrive flipped. There's like different topologies that you could choose to do. How are we on time? Wonderful. Well, thanks everybody.